needed when working with very hot or very cold materials. Respiratory protection in the lab ranges from the simple filter mask to the air-purifying cartridge respirator to the self-contained breathing apparatus. No matter what kind of respirator you use, you must be tested for a proper fit. If a respirator does not fit properly, it will not protect you. Hazardous fumes may leak in through the gaps between the mask and your face. When selecting PPE, consider all the hazards that a material presents. For example, when working with cryogenic liquids, you need to wear goggles and a face shield to defend against splashes, and insulated gloves to protect your hands. If you are ever uncertain as to what protection to use, ask your supervisor. Guessing about PPE can have serious consequences. Laboratory hoods can also protect us from hazardous chemicals, but only if we use them properly. As you know, a lab hood is a ventilated enclosure that helps contain fumes and vapors. But in order for it to do its job, we can't block the flow of air. A lab hood can also act as a physical barrier against spills, splashes, and explosions, but only if we do our part by lowering the sash when we work. Remember that a lab hood is a tool for your protection, not a storage cabinet for materials or equipment. Storing chemicals this way can be dangerous, especially if they are flammable or reactive. Always return supplies and glassware to their appropriate storage places. Speaking of glassware, improper handling of glassware is the leading cause of accidents in the lab. When hazardous chemicals are involved, little accidents can develop into significant exposure situations, so we have to work safe from the start. Inspect glassware for cracks, chips, and other flaws before using it. Even a hairline crack can cause big problems, especially if you add heat. Heating glass causes it to expand, putting pressure on the flaw until it fractures. When handling heated glassware, remember to use insulated gloves. Forgetting this could cause things to get out of hand. Returning equipment to its proper place and keeping glassware away from the edge of shelves and countertops will also help prevent problems. Sometimes, despite our best efforts, accidents just happen. We need to be prepared to deal with these emergencies. Before you work with a chemical or a process, consult the MSDS or your chemical hygiene plan. If there is a leak or spill of a hazardous chemical, quickly evaluate the situation. If people are in danger, evacuate the area. Safety is the top priority. Notify the appropriate personnel. Depending on how serious the spill is, this may be your supervisor, your facility's chemical hygiene officer, or an outside hazmat response team. If it's a spill that you can handle yourself, work to contain it. Use an absorbent pillow or neutral material to create a barrier around the chemical. Then you need to clean it up. Remember, not all chemicals should be handled the same way. Many chemicals can be absorbed with a non-reactive material, such as vermiculite or dry sand. Inorganic acids and bases need to be absorbed with a neutralizing substance, such as soda ash. Check the MSDS for proper cleanup procedures. Sometimes a chemical spill leads to an exposure situation. There are 4 basic routes of entry, or ways a chemical can get into the body: contact with the skin or eyes, inhalation, ingestion, and injection. Let's look at first aid procedures for each route of entry. If a hazardous chemical comes into contact with the skin or eyes, it could cause a localized reaction, or it could be absorbed into the bloodstream and circulated throughout the body. In these cases, water is your first line of defense against injury. Make sure you know the location of the nearest safety shower and eye wash. In fact, you should be able to find them with your eyes closed. because one day you might have to. If a chemical splashes into your eyes, get to an eye wash. Hold your eyes open and in the stream of water for at least 15 minutes. Your eyesight could be at stake. If a chemical splashes onto your body, call out for help and head for the nearest safety shower. You'll have to remove your PPE and your clothing. The shower water may be very cold, but remember, a corrosive liquid can cause permanent damage. You need to stay in the shower for at least 15 minutes, rinsing the affected areas thoroughly. Inhalation is another possible route of entry. If someone inhales hazardous gas, fumes, or vapors, the first step is to get that person out of the area and into fresh air. Next, let's look at ingestion. If someone swallows a chemical, consult the MSDS for instructions. They may need to take an antidote or drink water or milk to dilute the chemical. Injection is another route of entry to keep in mind. Needles aren't the only source of this kind of exposure. Broken glassware can also cause trouble. After any exposure to a hazardous chemical, report the incident to your supervisor and seek professional medical attention. Do this as soon as possible, no matter how minor the exposure may seem. Remember, even small doses of some chemicals can have serious health effects. So far, we've only talked about health hazards. That's because they're the focus of OSHA's laboratory standard. But we must protect ourselves from other dangers in the laboratory as well. Some chemicals can present physical hazards. These are covered by OSHA's Hazard Communication Standard. Working with flammable or combustible chemicals, for instance, requires special precautions. The safe handling of compressed gas cylinders is also very important. Chemicals are stored in these containers under great pressure. The rupture of a valve or cylinder can be extremely dangerous. OSHA's bloodborne pathogens standard focuses on protection from certain biological hazards. Precautions to take around viruses, bacteria, and other biohazards can be found in your facility's exposure control plan. Other types of hazards can also be encountered in the laboratory. Lasers, ultraviolet light, X-ray radiation. These all play important roles in the lab, but they can be dangerous if we don't take the proper precautions.
Exposure to various forms of radiation is another hazard sometimes encountered by laboratory personnel. The potential hazard associated with exposure to ultraviolet radiation, such as that created by arcs or torches, is a change in the structure of atoms. It is therefore important to recognize that such exposure can harm the atoms that make up living tissue and organs. With infrared radiation, such as that given off by heating elements, the primary change to the atom structure results in the heating of body tissue. In these instances, the skin itself usually provides its own warning mechanism, which causes pain before severe burns develop. Within the eye, however, there are no pain cells to alert us to damage caused by radiation. And since the eye has very few blood vessels to bring needed repair materials to the damaged area, injuries take longer to heal. As a result, conditions such as cataracts may develop from either acute or prolonged exposure. Since the eyes and skin readily absorb ultraviolet radiation, they are particularly vulnerable to injury. For instance, intense ultraviolet light from arc welding machines can cause welder's flash, a temporary blindness. In some cases, permanent damage to the sensing portion of the eye may result from such exposure. High-energy radiation has the greatest penetrating power and is commonly known as X-rays